Okay? Now, using this concept and using that definition, okay, we are using this concept over here. We can rewrite this is equal to what? Integration d mv dt dot dr. And immediately we can recognize dr over dt is again velocity. Therefore, dmv dot velocity is what? mv squared, right? Therefore, we obtain that work done induce change of kinetic energy. That's what we learned in the last lecture. One of the things we learned in the last lecture, right? Okay. And also we found that work done was special case if the force follow the following characteristics. In other words, force I am integrating over some circle or closed loop. If it is 0, then force is conservative. In this case, work done in this case is the same as, if that is true, then work done turns out to be what? Potential energy difference. So in this special case, combining this concept with that concept, we can say energy is conserved. Okay, that's the whole story. Right? And then we move to another principle. What was it? Anybody can remember? We learned Newton's second law, and we learned principle of work done, kinetic energy relation. And what we learned in the last lecture, what was it? Anybody can remember? Impulse and momentum. That also come from Newton's second law. So again, we thought about F equals to D, dt, and V. Again, using this mathematical expression, we thought, oh, what if I change this expression? What does it mean? Okay, now physically it means that if I apply the force to this body, I feel pain. But if I apply the force into this body during certain period of time, dt, then this mass and this mass will change so-called momentum. So integrating, in other words, I want to accumulate F dt, which we call impulse. So we introduce the concept of impulse. Or this can be written F delta t, that is the time duration that the force is applying to the mass of interest. This will induce d integration dmv from 1 to 2. Therefore, I can write this is mv if mass is constant. 2 minus m v1. So again, principle of impulse and momentum. Like energy principle or work done, principle of work done and change of kinetic energy is state concept. So I can write this, okay, moving this one over there, and I can write momentum as state 1 plus impulse I'm applying 1 to 2 has to be balanced by momentum at state 2. All right? So we learned 3 different laws or principles. That's very interesting. Now, I gave you 3 tools in your pocket. And it is your responsibility to select one of the tools from your pocket. Which tool you want to use to tackle the problem in front of you. It's your responsibility. And to select the appropriate tool, you have to know the characteristics or properties of the tool. Okay, so let's review that. First, Newton's second law. Okay, it involves force, mass, and acceleration. So it is very obvious if the problem in front of you involves force, mass, and acceleration, you select, hey, Newton's second law, come to me. Okay? This is the first case. Principle of impulse and momentum. What does it involve? Force, time duration, and velocity change, not acceleration. Okay? Maybe you can say that, oh, if I apply Newton's principle of impulse and momentum at every instant of time, then I can come up with Newton's second law, because I do know the velocity change in every second, then dv dt I can calculate. Therefore, I can get acceleration. So there is some relation, of course. And what other principle? This is work done. That's third principle. What is involved? Force, displacement, and velocity. Right? So the problem in front of you has force, displacement, and velocity has to be solved, or at least to find out, we have to find the relation of those 3 variables. Then principle of work done and kinetic energy is the tool we have to select. So the classroom homework asks you to apply those 3 rules or tools for pendulum problem. Okay? So pendulum, there's a pendulum you release from certain height, and you want to see or you want to find out something. Maybe you want to find out tension. Maybe you want to find out all the acceleration through certain trajectory, and so on and so on. I mean, you use a single example and apply those three tools. And I would like you to feel about the property of those three tools. That's the objective of classroom homework, right? Okay, now